Hello, my friends. Thank you very much for subscribing to our channel. We put a natural number on each vertex of the pentagon and demand that two adjacent numbers are coprime. Non-adjacent numbers are not coprime. So, among those 5 numbers, what is the minimal value of the largest one? Why not give a try, and we will come back soon. Generally speaking, it is easier to start it by focusing on the non-coprime ones than the coprime, because if some ones are not coprime, we can discuss their common factors. So we now start it by plotting all the diagonals of the pentagon. The numbers at both ends of each diagonal are not coprime. We write one of their common factors that is bigger than 1 on the diagonal. For example, n1 and n3 are not coprime. They must at least have a common factor a, that is bigger than 1. n1 is equal to a multiplied by a certain natural number. n3 is equal to a multiplied by another natural number. n1 and n4 are not coprime. They must also at least have another common factor d that is bigger than 1. Then n1 is a times d times a certain natural number. Please don't forget that n3 and n4 are coprime. So a and d must be coprime, otherwise if a and d had a common factor that is bigger than 1, then n3 and n4 would also have this common factor bigger than 1. In the same way, the 5 factors a, b, c, d, e on the diagonals are all coprime to each other. And n1, n2, n3, n4, n5 can be written as the product of the two of those factors, and then multiplied by another natural number. Because we ultimately demand the minimum value, meaning that under the conditions, n1, n2, n3, n4 and n5 should be as small as possible. So we just set all the factors except for a, b, c, d, e to 1. As for a, b, c, d, e, they should be the smallest 5 numbers that are coprime to each other, that is, the smallest 5 prime numbers, 2, 3, 5, 7, 11. 2 times 7 equals 14, 11 times 3 equals 33, 2 times 5 equals 10, 3 times 7 equals 21, 5 times 11 equals 55. Are we done? Actually, no. You know, we have 5 factors. To select 2 of them to make a number, we have a total of 10 options, but at the end we only need 5. That is to say, given 5 factors, the way through which we make 5 numbers by using 2 of them is not unique, therefore, we need to find the way where the largest number is minimal. How to find it? We denote the 5 factors from large to small as p1 to p5. Each factor will be used for twice to be multiplied by 2 other factors respectively. If we expect the result of multiplying the biggest p1 by the other 2 to be as small as possible, we would choose p4 and p5. Obviously, p1 times p2 must be bigger than p1 times p3, further bigger than p1 times p4. And p1 times p4 is bigger than p1 times p5, p2 times p4, etc. The only uncertainty is about p2 times p3, but it must be smaller than p1 times p3. That means, if p1 had a choice to be multiplied by p2 or p3, their results would be bigger than this case. As for p1 times p4, and p2 times p3, which one is bigger, we have to do a specific calculation to find it out. Going back to the 5 factors, 2, 3, 5, 7 and 11, 11 is the largest one, so we need to multiply it by 2 and 3 respectively. So we have to exchange the positions of 5 and 2. Then, the 2 affected numbers are, 2 times 11 equals 22, and 5 times 7 equals 35. Therefore, the minimum value of the largest number is 35. Thank you for watching, and see you next time.